Good morning. In this video, we are going to study about RETE matching algorithm. So RETE is actually a pattern matching algorithm. It is actually a pattern matching algorithm. And this was developed by Dr. Charles L. Forgy. Charles L. Forgy. So, RET is actually a pattern matching algorithm. We have learned about pattern matching in the previous videos. So, it is actually a pattern matching algorithm. And the word RET or RET means, it is actually a Latin word that means net. Okay. So in RET pattern matching algorithms, we solve a pattern or we match a pattern using the net, or we use networks to solve the patterns. Okay, so that is RET pattern matching algorithm. So it is actually a very efficient algorithm for matching facts against the patterns or rules. So a pattern matching algorithm has got two components in it. Okay, the components are, the first, it has a rule set, and then it has got a facts. So what are rule set? Rule set is actually the set of rules required, that set of conditions or set of rules. Okay, so each of these rules in a pattern matching algorithm, that they give knowledge. They actually represent knowledge, and these rules are denoted using if then rules. These are if then rules. An example, if you say, like, you can say that, for example, if you say something like, if age greater than 60, then assign equal to senior citizen. So we have got a condition, that is if age greater than 60, and then we have got a conclusion. So this is actually a rule set. This is actually a rule, and a set of such similar rules give what? A rule set. Okay, here you say we are comparing a value called age here. So we are comparing a value called age. So this age is what? It is actually a data that we need to check a condition. We have to check this condition using the data what? Using the data age. So this is the data. So this data is called as fact. So fact is what? It is the data we need to check. We need to check a condition. So it is actually the data that we need to check a condition, a particular condition. So this is the condition here. We need a data called age to check this condition. So age is called a fact. Now we are going to study about, this is how every pattern matching algorithm works. So now what is the need for pattern matching algorithm? To understand the need for pattern matching algorithm, we have to see how a pattern matching algorithm works. So every pattern matching algorithm has got a thing called as rule engine. So when we learned expert systems, we have studied about inference engine. So we studied that inference engine is actually the brain of the expert system. Similarly, rule engine is the brain of the pattern matching algorithms. So what we do is that, what we actually do in every pattern matching algorithm is that we actually provide the rule engine, the rule set. We provide rule set to the rule engine, and what rule engine does is that it matches every rule in that. So it matches this rule, it matches another rule. Okay, so it kind of matches every rule in the rule set with the given facts. Okay, to decide what to execute the rule or not. So if we for suppose this this rule is checked, what it does is that it actually compares a fact with the given condition. So if this rule is satisfied, then we will execute the rule. We execute the then condition. Okay, then condition will be executed. Okay, so this is called as firing. So once a rule is actually checked or matched, and then what we will do is we will execute the then condition or execute the rule, and this is called as rule firing. Okay. So this is a pattern. So this process actually takes place simultaneously in the pattern matching process. So many a times this is not like this. It has got multiple conditions in it, like if age greater than 60 or age greater less than 5 and income greater than 35,000, then so what it does is that it kind of just satisfy all the conditions, just looks for every condition. So what happens is that it will check the first condition, then it will check the second condition, then the third condition. So you can see that in pattern matching algorithms, this step, this matching process and firing is actually done simultaneously, or it is done repeatedly. Okay, this is done inside a loop, or it is actually done repeatedly. So every time, so in each cycle, so this is done repeatedly, that is, it is done in a cycle way. So in each cycle, the list of facts will be modified. So once this condition is checked, what will it do? It will change the fact from income, age to income. It will change. Okay. So what it does is that after each cycle, the facts will be changed or modified. And that is, new facts will be added to the list or facts will be deleted from the list. So that is that after each cycle, the fact list is actually modified. So what it does that this modification can cause the previously unsatisfied patterns to be satisfied. Okay, if a pattern is not satisfied, and after that when you go, like for example, you go for this one, if age greater than 60, this is not satisfied. Okay, then what it will go, it will go for the or condition. Okay, this is satisfied. Now what happened, it was previously an unmatched condition, right? But now what happens, now it is satisfied. Okay, so this will cause the previously unsatisfied patterns to be satisfied. And in during each state, what we have to do is that we have to maintain and store the set of rules, the satisfied set of rules. We have to always store the set of satisfied rules in this case. So in most of the cases, what is happening is that the actions of the rules change only a few facts in the list. Okay, it will change only a few facts in the list. Now look at this example. Here we can say that in the first process, age is actually compared. So age is the fact here, and when we do the next cycle, still age is the fact here. So there is no change in fact in the first two cycles. So you can see that during the process of matching, sometimes only a few facts are changed. Now here comes the problem. But in most of this pattern matching algorithm, what you have to do is that you have to repeatedly match the same set of rules again and again. So this is called as factual redundancy, or factual or temporal redundancy. So what we are doing here is that we have actually satisfied a fact. We are actually evaluated a condition. Now what we are doing is that we are again evaluating the same rule. So this can cause something called as temporal redundancy, and this temporal redundancy can significantly increase the computation time. Now in RETE algorithm, we are actually trying to solve this condition. Okay, so that is what we are doing with the RETE algorithm. So what is the problem with rule engines? We are actually trying to evaluate the condition again and again. So there is something called as a temporal redundancy. So in RETE matching algorithms, we are trying to solve or trying to prevent this temporal redundancy. So now how we are implementing RETE matching algorithms. So that is RETE algorithm implementation. So in RETE algorithm, we implement RETE algorithm using a network of nodes. We use a network of nodes. So in RETE matching algorithm, the basic thing that we do is that we save the state of matching process. We save the state of matching process. After each cycle, we will save the state of the matching process. Okay, and then we will only recompute changes only for the changed facts. Only if the facts are changed, or only for the changed facts we will recompute. Okay, so what we can do is that, okay, we can reduce temporal redundancy by, because we are actually we are updating the matching process only if the facts are updated. Only if the facts are updated, only then we will actually go for a matching again. Okay, we will update the matching process only if the facts are updated. So suppose the number of facts added or removed are less, then what will happen? The RETE algorithm gets faster. If the number of facts updated are less in number, then the RETE algorithm will be completed faster. So we are going to study about the structure of the RETE machine, or RETE structure. So in this we have got facts, then there is a rule engine, and then we have rule set. Okay, now what we are going to do is that in the inference cycle, so there is an inference cycle, because we are actually going and checking the condition in a cycle form. So in this inference cycle has got three phases. The inference cycle has got three phases. The phases are matching phase, select, and execute phase. So as the name suggests, in the matching phase, the conditions. So in the matching phase, the conditions are evaluated in the matching phase. Okay, the rules or the conditions are met during the matching phase. So the rules, so in here we are getting the rules and the facts to the rule engine, and we go for a matching process. If the rules are satisfied, then we will store that in an agenda table. So all the rules that are satisfied will be stored in the table called agenda. Now there is something called a select. So what we are doing is, we are actually selecting rules from the rule set. So this selection process can depend upon priority, recency of use, etc. Okay, so we actually select rules in the rule set and give it to the rule engine. That is the select phase. Now what is the execute phase? After the matching process, if the rules are satisfied, then we will execute the rules. Okay, that is in the agenda table, all the rules stored in the agenda table are executed after the matching process. This is called as the execute phase. So another name for execution is also called as firing. So execution is also called as firing. Now we are going to study about the building of RETE network. So RETE network. So what is RETE network? RETE network is a directed acyclic graph. RETE network. It is actually a directed acyclic graph. Okay, this RETE network has got two networks, or two parts. It has got an alpha network and got a beta network. Okay, so in alpha network, the alpha network consists of nodes, and the nodes in the alpha network are called as alpha nodes. And each alpha node has only got one input. So that input actually define the intra element condition. Okay, intra element condition. So alpha node has got only one fact or one input in it. What beta network consists of? Beta network consists of nodes called beta nodes. Okay, in beta nodes, the beta nodes take two inputs. Instead of one input, it takes two inputs. And it defines inter-element condition. That is a condition between two elements like and, or, etc. Okay. So the RETE network actually start with a node called as the root node. This is called as the root node or RETE node. The root node is also called as RETE node. And then the root nodes are actually followed by kind nodes. These are the kind nodes, kind 1, kind 2, kind 3, etc. Okay. These are also followed by the kind nodes. Okay. So that is, there should be a kind node for each fact type. That is, for example, if we say the example that we have said before, here if age greater than 0 or age less than 5, then income greater than 35,000. Here what is the number of facts here? 2, right? Because there is an age fact and there is an income fact. So the number of facts is 2. So here we need how many kind nodes? 2 nodes. Okay. So kind nodes. Then these kind nodes are then split into alpha nodes. They can be 1 or 2 or 3 alpha nodes. Okay. Alpha nodes depends upon the number of conditions. Okay. That is called as the alpha nodes. Now what we do is that we will combine the alpha nodes to form beta nodes. Okay, so in beta nodes we have to remember one condition, that is in beta nodes only 2 alpha nodes can be combined. Maximum 2 alpha nodes can be combined to form a beta node. So suppose if there are 3 alpha nodes, this is alpha 1, alpha 2 and alpha 3, then what we do is that we will combine the first 2 alpha nodes and then we will combine the third alpha node with the beta node to form. So we will combine this like this to form the next beta node. I'll show you an example and then we will understand. So let's take the example like this. Okay, if age greater than 60 or age less than 5 or income less than 36,000, then price is equal to 1 by 2. Okay. Okay. So here what we are doing is that if age greater than 60 or age less than 5 or income is less than 36,000, then price is given as half. Okay. So here let's make the graph. Okay. So this is the root node. Root node. So this is the root node or the RETE node. So how many facts are here? There are 2 facts, right? Age and income. So we will make 2 kind nodes. That is kind 1 and kind 2. Kind 2. Okay. So kind 1 will be up to here and kind 2 will be up to here. Okay. This will be kind 1 and this will be kind 2. Okay. Now let's check kind 1. In kind 1 there is 2 conditions needs to be satisfied. Age greater than 60 or age less than 5. Then what will we do? We will make 2 alpha nodes. Okay. Making 2 alpha nodes. First one is age greater than 60. Then second one is age less than 5. Okay. Then in kind 2 what is it? Income less than 36,000. Income less than 36,000. So this is alpha 1, this is alpha 2 and this is alpha 3. Now what we are going to do is that we are going to combine alpha node and beta node together. Alpha node and beta node together. Alpha nodes together to form a beta node. Okay, we are going to combine these alpha 1 and alpha 2. Why we are combining only 2? Because the maximum number of alpha nodes that can be combined is 2. So now we will be combining that. So then the condition is age greater than 60 or age less than 5. So this is beta 1. Now we are combining this. We are combining beta 1 with the alpha 3. We'll combine that. Now what we'll get? Age greater than 60, age less than 5, income less than 36,000. This is beta 2. This is beta 2. Now what we will give? We will give the final condition. What was the final condition? Price is less than, price is half, right? Now the final condition, or this is the terminal node. Price equal to 1 by 2. So this is what? This is the terminal node. Now here look, we are actually combining a beta node with an alpha node, right? This is called alpha beta pruning. We are combining an alpha node with a beta node. This is called as alpha beta pruning. So this is how we satisfy partial matching in RETE algorithm. So only if this condition is satisfied, we'll go for this condition, right? So we are only going for partial matching. We are not repeatedly evaluating the same condition again and again. So this is called RETE matching algorithm, and it is implemented to reduce what? It is